You're listening to the N2K Space Network.
Quick question. Do your end users always, and I mean always without exception, work on company-owned devices and IT-approved apps? I didn't think so. So my next question is, how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question: Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device because it solves the problems traditional IAM and MDM can't touch. And it's now available to companies with Okta and Microsoft Entra and in beta for Google Workspace customers. Check it out at 1password.com/cyberwire. That's 1password.com/cyberwire.
The Artemis Accords, created, and I quote here, to establish a common political understanding regarding mutually beneficial practices in the exploration and use of outer space, well, they launched on October 13th, 2020, with 7 signatories joining the United States at the outset. And here we are a smidge over 4 years later, and we are on the cusp of signatory number 50 coming on board.
T-minus 20 seconds to LOS egress. Go for deploy. Roger, roll.
Today is December 10th, 2024. I'm Maria Varmazes, and this is T-minus. Viasat has been awarded a $568 million GSA IDIQ contract. Redwire to develop AFRL software and hardware. DIU picks Aalyria to enhance defense applications. And our guest today is astrophysicist Jonathan McDowell. Jonathan co-authored a paper on rocket launch and reentry, air pollutant, and CO2 emissions at the onset of the mega constellation era. What we know and what we don't know, which he'll be talking to me about later in the show. We're kicking off today's Intel briefing with a slew of contract news. The first big announcement comes from Viasat, who have been awarded a 5-year sole source Indefinite Delivery, Indefinite Quantity, or IDIQ contract through the U.S. General Services Administration with a $568 million ceiling. The contract is an extension to a previous IDIQ issued in 2019 to deliver a diverse portfolio of technologies and services to help advance and enable the communications, security, intelligence, and operations that are essential for U.S. warfighters. Viasat's contract supports the rapid migration of command, control, communications, computers, combat systems, intelligence, surveillance, and reconnaissance capabilities, and best practices, from special operations forces to general purpose forces. The new contract structure allows the U.S. Department of Defense to address key priorities for enhanced mobility, resilient networking, cybersecurity, and broadband SATCOM services. It also allows for the accelerated acquisition and adoption of new products, systems, and services that the DoD requires, and enables military users across services to access and benefit from these emerging technologies. Redwire has been awarded a $45 million plus 5-year cost-plus fixed-fee contract for the design, development, and testing of prototype software and hardware for mission-critical technologies. The contract will support the AFRL Space Vehicle Directorate's efforts to equip the joint warfighter with a spectrum of agile, effective, resilient, and affordable space mission capabilities. Aalyria has been selected by the U.S. Defense Innovation Unit to enhance connectivity for defense applications. The contract was awarded by DIU for the Opportunistic, Resilient, and Innovative Expeditionary Network Topology Project, also known as ORIENT. Aalyria will play a key role in advancing resilient command and control for all domain-attributable autonomous systems in support of the Replicator initiative. NASA, on behalf of NOAA, has selected the Southwest Research Institute of San Antonio to build the next-generation space weather magnometer for the Lagrange 1 series project as part of NOAA's Space Weather Next program. This cost-plus fixed-fee contract is valued at approximately $26.1 million and includes the development of 2 magnometer instruments. The anticipated period of performance is from December 2024 through January 2034. Rocket Lab successfully launched a suborbital mission in November to test hypersonic technology for the Department of Defense. The mission provided hypersonic test launch capabilities under the Multi-Service Advanced Capability Hypersonics Test Bed Project, which aims to increase hypersonic flight testing for the United States in support of technology maturation. Rocket Lab's test platform showcased a new suite of technologies optimized for hypersonic technology tests with vastly increased payloads. Rocket Lab also designed, manufactured, assembled, and integrated the experimental hypersonic instrumentation, which was launched on this mission on a highly accelerated timeline. Lockheed Martin's newest technology demonstration is complete and ready for launch in 2025 aboard a Firefly Aerospace Alpha rocket. The tactical satellite known as TACSAT is an intelligence, surveillance, and reconnaissance spacecraft with a mission to provide specialized sensing and communications capabilities on orbit. The satellite will participate in exercises next year that highlight cross-domain kill web connectivity, enabling timely execution of tactical space missions. Earth observation company Planet Labs has announced financial results for the period ended October 31st, 2024. The company reported that their third quarter revenue increased 11% year over year to a record $61.3 million. Planet has signed key contracts with domestic and international partners over the last year to provide satellite imagery to increase awareness for defense, maritime, and deforestation situations. Sierra Space is collaborating with NVIDIA to predict the future locations of orbital debris. Sierra Space says it's leveraging the power of physics-informed neural networks to develop a solution that not only enhances prediction accuracy, but also significantly reduces computational overhead. The collaboration uses NVIDIA AI and accelerated computing for both training and inference, providing Sierra Space with models that can achieve heightened computational efficiency and speed. Japan's iSpace and lunar resources company Magna Petra have agreed to collaborate on future missions to the lunar surface. Magna Petra is aiming to prospect, extract, and return to Earth helium-3 isotopes from the lunar surface. The two companies have agreed to collaborate on the development of a lunar economy that provides terrestrial economic value via non-destructive, sustainable harvesting of lunar surface resources. French space propulsion company IonX has raised 13 million euros in a funding round. The company is aiming to launch the industrialization of its ion thruster for small satellites and accelerate its development in France and internationally. The company plans to produce 200 ion thrusters per year by 2028 at its future production facility in the Ile-de-France region. And Panama and Austria will sign the Artemis Accords at NASA headquarters in Washington tomorrow. NASA will be celebrating reaching 50 signatories after the event, and we'll bring you more on that in tomorrow's show. Head to the selected reading section of our show notes to find links to more information on all the stories that we've mentioned today. And we've included the NASA blog on the experiments being conducted on the ISS this week. Hey T-Minus crew, if you are just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. Also do us a favor, could you share the intel with your friends and coworkers? Here's a little challenge for you. By Friday, you can show 3 friends or coworkers this podcast. A growing audience is the most important thing for us, and we would love your help as part of the T-Minus crew. So if you find T-Minus useful, please share so other professionals like you can find the show. Thank you. It means a lot to me.
Identity architects and engineers, modernize your identity systems with Strata. Integrate legacy apps with any IDP, ensure seamless identity failover, and apply MFA without touching app code. Strata offers robust, efficient identity management, reducing tech debt and enhancing security. Gain peace of mind and operational efficiency with Strata's comprehensive solutions. Visit strata.io/cyberwire, share your biggest identity challenge, and enjoy free AirPods Pro. Optimize your identity solutions today. Visit strata.io/cyberwire. And our thanks to Strata for being a longtime friend and supporter of this podcast.
Our guest today is astrophysicist Jonathan McDowell. Jonathan co-authored a paper on rocket launch and re-entry, air pollutant, and CO2 emissions at the onset of the mega constellation era. And I asked him first to explain at a high level what the paper was about.
For 50 years, we've been using the upper atmosphere as an incinerator for old satellites. And the statement was always that there's tiny amounts and it won't affect the upper atmosphere. But the amounts aren't as tiny as they used to be. And so we thought it was time to sort of reevaluate that. So the paper that I'm on is really just an inventory trying to assess how much material of different kinds is re-entering the atmosphere, burning up in the atmosphere, reaching the surface of the Earth, all of that stuff, and just to give a baseline input to the climate models. And so my collaborators, who are actual atmosphere scientists who know about the atmosphere, and I, who just know about rockets and how many are falling down, got together to make this. And what's coming in is a lot. It's a lot more than it used to be. It now exceeds, in certain respects, the natural influx of meteors and stuff. Not in total amount, but it's certainly in, for example, metallic elements like aluminum. And so that raises the question, okay, so now we know we can't neglect it relative to things that we already know are not a problem.
Right.
We've been living the meteor for billions of years, right?
Right. That's usually the hand wave that people give is that, yeah, yep. Mm-hmm.
Right. So now we have to ask the question, okay, so how much would be a problem? And we're not there yet. That's the short version. We don't know. But the fact that we don't know, and the answer may well still turn out to be no, even with mega constellations and everything, it's not enough to be a problem for the ozone layer or other issues with the upper atmosphere. But we don't know that right now, right? We have to do the science. We have to do the climate models. And so this is sort of a wake-up call of we really need to do this research now before we up the input levels by another factor of 10, right? And there's a whole bunch of things happen when you re-enter the atmosphere. I mean, one is that you melt, right? And your component molecules enter the mesosphere. And, it's just another source of pollution, right? But the mesosphere, which is like the upper layer of the atmosphere above 50 kilometers, is really thin. There's actually not that much of it. If you take the whole mesosphere and squish it down until it were ground level air density, right, it would be about the size of a town or something like that. So the ability to perturb that is much easier than the ability to perturb the lower atmosphere, right? Because there's just not that much of it. And so you're adding material, but you're also putting in shock waves. And the shock waves of the reentry compress the nitrogen that's already in the atmosphere and make it react with oxygen and make oxides of nitrogen and so on, which can be problematic. And so there's a series of effects. There's also, by the way, these reentries leave like what we call noctilucent clouds, the streaks of material in the upper atmosphere that you can see that could interfere with astronomy. And so there's like a series of side effects of these reentries that until now we've kind of gone, it's not enough to worry about. And now we're going, we should check that it's not enough to worry about.
That is a very measured way of putting that. I do appreciate that. So some of the takeaways that I was getting from this, and again, I this is way outside of my knowledge sphere, so please correct me here. There's sort of a multiplier effect because I'm sort of trying to do a sum up version of it's not just how much is going in, but also being in the mesosphere, that there's a multiplier effect of the certain materials that are there. Am I understanding that correctly? Or?
Well, okay, now you're getting into the chemistry that I don't understand. But my limited understanding is that there are catalysts, right? That a small amount of certain materials can facilitate certain chemical reactions that are happening with the other materials that are there and make them go more quickly and so on. So I think that's what you're getting at. So, that all goes into these fancy climate models that are kind of the same kind of models that we use for predicting, climate change and things like that. But this is on a shorter time scale. And so it has, there are all kinds of inputs to the atmosphere. There's the solar X-rays, right, that create the ionization state. There's the natural meteor impacts. There's the stuff coming out from below, the radiant heat of the Earth. There's various kinds of pollution. And so you have to sort of mix all these in as a function of latitude, longitude, time in the solar cycle, all the different parameters that can sort of influence the atmosphere, and try and assess how this particular input changes the result compared to not having it in. So there's a lot of subtleties involved. It's going to take a while. And I don't know how the answer is going to come out. I think it still may well be that the input is too small to worry about overly at the moment. But if it isn't, we've got a real problem. And so we really need to know.
Yeah, get ahead of that for sure.
I
guess
for once in our environmental effect, let's get ahead of something, right?
It would be nice. It would be really nice. I won't lie. We could use some of that.
It would be a refreshing change.
They would. It truly would. Getting into just because I can't help myself, the hypotheticals, the conjecture part, putting more of the satellite hat on, taking the atmosphere hat off for a second. What if the conclusion is we have to stop re-entry? How? My goodness, would everybody just go to graveyard orbit? What on earth would we do?
Right, exactly. So then I do know some people who are working on a nice idea for a recycling yard in space.
Okay. ICM's really happy about that. Yeah.
Yeah, you're not just going to send something to graveyard orbit. You're going to send it to Tom's scrapyard in orbit, and they're going to collect the materials and hopefully, reprocess them and reuse them for like shielding for satellites and things like that, right? It's probably unrealistic to think that you're going to get much active electronics out of such a recycling project, at least in the short term. In the long run, we'll have our satellite factories in orbit, and it'll be like, taking your satellite to the shop. But in the short run, you could imagine at least reusing the structures as shielding for deep spacecraft that want radiation shielding or something like that, or microwave shielding, right? And so maybe someone can make a business out of that, or maybe it will have to be a requirement, government tax funded or whatever to kind of do this to avoid but it's an extra overhead on running your space business in the long run.
Yeah, and we know how that goes for a lot of businesses, truly. What about materials changes? I don't even know. Again, who knows, right? But I'm just curious what your thoughts are. Yeah.
The Japanese just deployed their first wooden satellite.
Yes. Yep. I love that. That's so cool.
Yeah, that's lovely. Although there have been uses of wood in other spacecraft in the past, and so perhaps a different mix of materials would be more benign. So that would have to be. I think we have to understand the physics first before we can start redesigning things. But that would be a one way to go. I think it's going to be limited in that for some purposes you're really going to need. There's a reason we use the materials we do. Put it that way.
Well, I do really appreciate that you and your colleagues are looking into this. I know that this is the dialogue around this is really just beginning, and we're so in the preliminary stages, and there's so much still to learn. But I'm just glad that these discussions are happening and this research is happening. It's important.
And like I said, we don't know. And here's the thing about science, right? In my career, right, I've had maybe of like 100 investigations I've done, 80 have ended up with, okay, this isn't even worth the paper, right? You have to investigate all the possibilities to rule out the ones that, because you don't want to miss the one that's really important. And so when you hear about a scientific result in the media, you have to be a little careful. Okay, they wrote a paper, that's great. Mm-hmm. Good for you. But that doesn't mean it's the final word on the subject. And so very much in this case, this is like an early word on the subject. And I really hope that other researchers will plunge in and apply their own models and see if they can, do something better and more quantitative. And the group I'm working with will be doing that for sure.
A link to Jonathan's full report can be found in our show notes. We'll be right back. Welcome back. If it looks like an asteroid but behaves like a comet, it's a dark comet. No, it's not from a comic book, but it's a real thing, with the first dark comet discovered just less than 2 years ago. We're up to around a dozen dark comets known now. So what led to the discovery of dark comets? Well, in 2016, when asteroid, or then what we thought was an asteroid, 2003 RM, was being tracked, it ends up that its path was kind of odd, and 2003 RM was not moving in the way that an asteroid ought to. David Farnocchia of NASA's Jet Propulsion Laboratory co-authored the study on 2003 RM and said, when you see that kind of perturbation on a celestial object, it usually means that it's a comet with volatile material outgassing from its surface, giving it a little thrust. But try as we might, we couldn't find any signs of a comet's tail. It looked like any other asteroid, just a pinpoint of light. So for a short while, we had this one weird celestial object that we couldn't fully figure out. Kind of love it when space stuff is simply described as weird. When in 2017, Oumuamua, everyone's favorite interstellar object, came into the solar scene, it was also off-gassing, a little bit like a comet does, but moving like an asteroid. And that made scientists take a closer look at 2003 RM. And later, it changed its designation from asteroid to dark comet. And the latest in dark cometry, just published in the Proceedings of the National Academy of Sciences yesterday, in fact, is that there are small dark comets that roam the inner solar system in nearly circular orbits and larger outer system dark comets with highly elliptical orbits. So not only did we get a whole new brand new category of celestial object last year, there are now subcategories to that new category. That is it for T-Minus for December 10th, 2024, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth. Our associate producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karp. Simone Petrella is our president, Peter Kilpie is our publisher, and I am your host, Maria Varmazes. Thanks for listening. We'll see you tomorrow.